Hello, and welcome to our next section for our Tools of Geometry, Chapter 1 unit. We are going into angle relationships. This is our table of contents. Pause the video if you needed. This is also going to be on the last, it's going to be my page 8. So get the title down, and let's get into it. We have a lot of different angle relationships that we need to know. We're going to be using these throughout the pretty much the entire year. So the first one is the word adjacent. Okay, and adjacent, specifically adjacent angles they're just angles that are adjacent, but the word adjacent, I'm going to put this above in quotes, means next to. So for instance, if whoever you're sitting next to in class is adjacent to you. In this particular case, we have adjacent angles. That means two angles that are next to each other. Even more specifically, these are two angles that are next to each other. And let's actually close this out because we don't need that. That share a common side and vertex. Side and vertex. So let's draw one out. We're going to draw an angle. Okay? And that's not an angle. Let's draw this straight. Here we have just one angle. The vertex, remember, is where those two sides meet. And then we're going to draw a pretty much a ray down the middle. So it's dividing the angle into two angles. They're not necessarily a bisector and the angle bisector. It's just, splitting it into two. So now we actually have three angles here. So I'm going to go ahead and say that I'm going to put some points here just so we can label it. I'm going to put M here, O, L, and then E. Okay. So here's our mole. M-O-L-E angle. M-O-E, technically, big angle. Mole, M-O-L, mole is one angle. So angle M-O-L. We could also say is adjacent to angle L-O-E. Okay? Because if you note, they actually have a common vertex. It's written in, you can see it in the name, L-O-E and M-O-L share the common vertex O. So this is important. Common vertex is O. And the common side is the side that they both share, O-L, sorry. And it's also in their name. The common side, common is O-L. And it's a ray, so we're going to put one arrow. Okay? So that is what adjacent means. Now, complementary is a new definition as well. It doesn't, this is complementary. Now, it's opposed to complementary. Complementary angles are two angles, or a pair of angles, whose sum means what they add up to, is 90 degrees. Okay? So, let's draw a right angle. Because a right angle is 90 degrees. The way you know an angle is right, hopefully you remember this from the last lesson, is that the angle has a square at the angle. Okay? This tells us that this is 90 degrees. Then we're going to draw an array from the vertex to split that right angle. I'm going to call this angle 1 and angle 2, because remember we could name angles by numbers. As long as it doesn't have degrees there, that's perfectly fine. And then now we could say, okay, angle 1 is complementary. So it's just a variation of never mind. Angle 1 is complementary to angle 2 because together, angle 1 plus angle 2 equal 90 degrees. Okay? They don't have to be adjacent to each other. Okay? So here's another variation of this. I'm going to draw underneath it. Nope, didn't mean to do that. I'm going to say that this is angle 4. Or angle 3, sorry. I'm getting ahead of myself. Angle 3. Actually, even better. Let's call this DOG. I'm going to call this 60. This looks close to 60 degrees. Then I'm going to draw another angle, slightly smaller one. Could still be long, but the angle is smaller. I'm going to call this one cat. And this is going to be 30 degrees. And if you notice, 60 and 30 add up to 90. So we could here say that angle DOG, I'll put this lower, is complementary to angle CAT. Complementary to angle CAT. So they don't have to be adjacent to each other in order to be complementary. It's a very important feature. Okay? So, adjacent done, complementary done. Moving forward, we have 4 more. Actually, we have a lot more. So let's go. Okay, let's get this running. We have something called supplementary. Supplementary angles is the same concept as complementary angles, except instead of 90 degrees, we are working with 180 degrees. So supplementary angles are a pair of angles whose sum is 180 degrees. So just like we did with complementary, we could have a straight angle. Okay, anytime you see a straight line, you could assume it's 180 degrees. I'm going to draw a ray at some random vertex. I'm going to call this angle 3. I call this one, the bigger one, angle 4. And you could say angle 3 is supplementary. Now, over time, I'm probably going to shorthand supplementary to SUPP to angle 4. And you could actually switch these numbers around too. Angle 4 is supplementary to angle 3. We could even break this apart and say, for instance, let's put a P, I, and G. I'm going to draw another angle here. Let's call this A and T. Let's put 120 degrees here, 60 degrees here. Now, if you're wondering why, okay, I put one angle tick here and one angle tick here. I'm allowed to do that because I actually give the angle measure. So since I wrote the angle measure here, it doesn't mean I have to put 2 ticks on, for instance, 60 degrees. It doesn't change. If you have the angle measure there, it's perfectly fine to just use the one angle tick. Okay, so together these add up to 180. So you could say that these are supplementary as well. So angle PIG is supplementary, and here I'm going to shorthand it, to angle ANT. Okay? All right. Supplementary done. Now we have what we call a linear pair. Linear pair is very much similar to, actually here, before we do that, there's a little kind of mini shortcut to knowing the difference between these two, because these are 2 completely new definitions. Supplementary, complementary. Well, alphabetically, C comes before S in the alphabet. Same thing goes for angles. 90 degrees comes before 180 degrees. So that's a very kind of like nice and neat way to remember, okay, complementary, 90 degrees, supplementary, 180 degrees, put them in the alphanumeric order. Okay? Now, linear pair. I'm going to keep supplementary angles here because it is very much related to it. A linear pair are a pair of angles that are a pair of adjacent angles. Sorry. Whose sum is 180 degrees. So in reality, the linear pair, if you look above, is this example, this first one, angle 3 and angle 4. They are both adjacent and add up to 180 because they make a straight angle. The second example, however, is not a linear pair. They're only supplementary. So the shortcut to this is, you could say these have to be adjacent and, I'm going to capitalize and underline it, supplementary. Or the other way to think about this is, does it make a straight angle? Do they make a straight angle? Straight angle means one line. So those are the two kind of schools of thought for that. Does it make a straight angle? Okay? And I'm going to say, see example, first example, I should say. See first example from supplementary angles. Okay? Or if you want to just redraw it, you absolutely could. Angle 1, angle 2. So, there you go. Linear pair. Done. Another set of angles that we need to know are vertical angles. We will use this a lot as well. Vertical angles. Kind of like the roller coaster ride vertical velocity, which is always closed down at Six Flags, are two non-adjacent angles. Already, this is adding some new definitions. Non-adjacent angles with the same vertex that are formed by two intersecting lines. Okay, so we have two intersecting lines. That's probably the starting point of this. Let's draw the diagram. Two intersecting lines. They meet. Okay, and let's put some angle numbers here. 1, 2, 3, and 4. They meet at this point in the middle, the vertex, for all four of those angles. So we have some adjacent angles and non-adjacent angles. For instance, 1 and 2 are adjacent. They're next to each other. But 1 and 4 are also adjacent. They're next to each other. But if we look at 1 and 3, these are non-adjacent. They also have the same vertex. And they also are formed from two intersecting lines. So 1 and 3 are vertical angles. Let's say angle 1 is vertical, or angle 1 and angle 3 are vertical angles. Angle 1 and angle 3 are vertical angles. So you could also say angle 2 and 4 are as well. So I'm going to put this here. There's a small caveat to this too. Notice that I'm putting two different sets of tick markers, and I'll explain that in a second. Angle 2 is vertical, this is a different way to say it, is vertical to angle 4. Okay, and here's the kicker. Vertical angles, I'm going to shorthand this, vertical angles are congruent. Meaning, if angle 1, I'm going to put this in pink, don't copy this down, was 100 degrees, we could then assume angle 3 is also 100 degrees. If we change it, if I said this was 120 degrees. Angle 3 would also be 120 degrees. Same thing goes for 2 and 4. Okay? 3 more definitions. Let's see how fast we can get through these. Whew, we're flying through this. I'm trying to fly through this. We have something called an altitude. An altitude is a segment drawn from the vertex of a triangle Oh, I forgot, I missed one. I'm sorry. This is going to have to pause. I'm going to have to carry that down. Sorry about that. I missed the definition. We need to know perpendicular before we can do altitude. So, perpendicular. Perpendicular is a new term as well. It is a line, segment, or ray. Or rays. These are plural. Lines, segments, or rays that intersect and form 90-degree angles or form right angles. Form right angles. So for instance, we have two lines that intersect, kind of like the XY plane. They are perpendicular if they form a right angle. Okay, we have a very specific symbol for this as well. So for instance, if I put this here and I put FLY, okay, we could say then that FL, I'm going to draw a line, make this a line, FL, and this is the new symbol, is perpendicular, it looks like an upside down capital T, to LY. So this symbol here means perpendicular. So we have new symbol as well. Okay? All right. Altitude. So sorry if you had to scratch all that out. Altitude is a segment drawn from the vertex of a triangle that is perpendicular. I have enough room. Perpendicular to its opposite side. Okay, so let's draw a triangle. All right, here's a triangle. Vertex at the top, just for simplicity's sake, T, R, I, and then I'm going to draw a vertical line straight from that vertex down, and I'm going to put a G here. So, in order for this to be an altitude, it needs to form a right angle. We need to put either 1 or 2 squares at the very base of it. Okay? So we would then say RG is the altitude. Okay, of the triangle, of triangle TRI, sorry. All right, altitude is now done. Last but not least, we have something what we call a perpendicular bisector. Now this is 2 definitions in one. We talked about perpendicular today. We talked about bisectors in the last lesson. It's kind of, if you know both of those definitions, it works itself out. A perpendicular bisector is a segment that is perpendicular, so the upside down capital T, and bisects another segment. Oops. Bisects another segment. And we actually have this a lot with like triangles. So you could actually have a triangle where it would drop down, kind of like an altitude. It would form right angles at the base, and it would bisect the angle. So it would cut this, or it would bisect the base, I'm sorry. Bisect the base. So it would cut that base perfectly in half. It would create a midpoint here. So, for instance, if we put this as B, A, D, and C, this would be, BD would be the perpendicular bisector. Perpendicular bisector. Now, it's not always going to be, the perpendicular bisector doesn't always happen at a vertex. I'm going to draw a second example here. Triangle that's kind of slanted. It could be a perpendicular bisector in this regard too. If we look for the midpoint of this base, it is just perpendicular to that base, and it creates two congruent segments at its base, or at that side. So in this particular case, if I call this X, Y, Z, and V, and even W, then we would say VW is the perpendicular bisector. To X triangle XYZ. Now let's say perpendicular bisector for now. All right, so a whole bunch of definitions. Make sure we know these. We could use these fluently. And if you do have any questions, please let me know. We'll get a ton of practice with these. And I'll see you in the next one.